Houston. It's great to see you. We desperately need you at Marco Learning because we're good at English and Espanol and history and not at physics, but you are. It's amazing that we've got such a great group here in the chat. Welcome everyone as you're coming in. Go ahead and press that like button. Tell us where you're coming from, what topics you need help with. One of the things that I really want to emphasize, I'm just going to mute this. One of the things I really want to emphasize is that there's more resources on our channel for physics than you might realize. Gina has done this review actually a couple of times with us. And last year, she has a review session, 2 review sessions that you can access. And we'll be adding resources to this list as we go. So definitely check out the AP Physics videos on our channel. Gina, I'm gonna turn it over to you to let us know what we're gonna be covering. Everyone post your questions in the chat as we're going through this session and let us know how we can help you.
Yes, definitely. Well, thank you very much. I'm glad to have you guys all here. Wonderful to see you. I know you probably are feeling a little nervous. Oh my goodness, the test is tomorrow. You got this. You can do this. Okay. You guys have studied all year. I know some of you have been working with me on weekends and stuff. So we're going to just kind of plow through today. And most of what I want to go over today is to try to help you maximize yourself for tomorrow, because we all get nervous when we take tests. Me too. Okay. And so I'm going to kind of warn you of some pitfalls that we tend to do. Please, please, please. The best way to have me answer a question, put it in the chat. So if you can find that chat for me and put it in the chat, and I tend to check that pretty regularly. So that chat is on the side. Please make sure you put it there. And the handouts and stuff are on the website that John was mentioning, and there are old videos there, not old, recent, let's put it that way, recent videos there for you to be able to see. If you ever need something, contact us here at Marco Learning. We'll be happy to point you in the right direction, get you to the right video or assistance or handout so we can get going. Kind of what I'm doing today, as I said, is kind of test days. What's going to be in front of you? What are our time limits? What are some special things about MCQs and FRQs that you should be looking at? Couple of common pitfalls that we as humans do that you can kind of guard against, which is perfect. And just a little bit of a unit review on graphing. Hopefully that you'll have that. So test day is here. We're going to be so excited to finish tomorrow. So to remind ourselves of what's ahead of us, we've got multiple choice first, then we've got our free response. I know you know, but just to let it run through your brain one more time. If you're taking the regular test, it's going to be 90 minutes multiple choice, 10-minute stretch, 90 minutes free response. Now, if you do, I will go there. Definitely. Thank you. If you do have an IEP or something of that nature, most of you will be getting time and a half. So realize that first section would be longer, second section would be longer, okay? Remember, first section, we're going to have basically 50 questions. The last 5 are going to be our multiple response. So on those multiple response, you got to get both things right to get that grade. For our free response, remember, you have 5 questions that you're going to be working on. So how to gauge my time? Ooh, they just gave me the test. What am I going to do? Okay. Those people asking about amplitude, I promise I will get there. Just give me a second so I can have a little bit more space on my slide. Time limits, all of your multiple choice, look at yourself in under 2 minutes. Okay. You're reading the question, you're going, and all of a sudden you notice that you're spending more time than 2 minutes. Please, if you don't have the answer, move on. Every single question there counts for the same amount. So if you're stuck on number 4 and you can answer 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, 10 are going to give you the points. Come back to that question that you're struggling with right at the end. Don't get stuck. Usually if you're getting stuck like that, that's when your score starts to go down. So we want to answer as many as possible. For our free response, remember we have our 2 biggies, our experimental and our QQT. Those 2, I want you to spend in the ballpark of about 25 minutes-ish, okay? On those short response ones, you have 3 of them, give me about, say, 13 minutes. And remember, on those short response, one of them is that paragraph style one we've been practicing. So please do kind of pay attention to the time as you're going and look at the questions you know first. So in other words, as you're going, you get to something your teacher didn't cover. Skip that one, keep going, okay? Every question's worth the same amount. So move along so that you get as many as possible. In the olden days, ooh, I won't tell you how old, but in the olden days, they used to penalize you for guessing. Now they don't. So please, everything, put a bubble so we know what your score is. Okay. Free response, it actually tells you on the question how many points it's worth. If it's a 12-pointer, those are your two big ones. If it's the 7-pointers, those are your small ones. Okay. Use all of your time to take the test. I don't want to hear of any of you putting your head down and taking a nap. Use every single minute possible. Usually on your multiple choice, you're looking to barely finish. On your free response, it's not that many people finish. Most of the time, you're hitting what you're supposed to or hitting what you know, and then going back and trying to revisit the things that you don't know. It's very rare that a person finishes everything on the free response. So you will be tight on time. If you do happen to be that person who finishes early, wonderful. Go back and check yourself, okay? But it doesn't happen frequently. Watch out for those keywords, except which of the following does not. You want to be careful of those because sometimes when you're reading fast and you're nervous, you forget and you answer what the most correct answer is instead of the one that's not. So be careful. Also, watch, and I do this too, and my students do this too. When you're working out that free response question, a number of the times, College Board's going to tell you the variables they want you to put that expression or equation in. Make sure that you do so. So if they're telling you to put it as V naught with the little zero, you best put your answer with V naught in it. Physical constants like, say, gravity as G, they want those. So make sure that whatever variables they're telling you, you use those. Also, watch it when they're changing scenarios because you're nervous, you're taking the test, you're gung-ho, you're doing the first part of the free response, and then they change it and something else is happening or something else is happening in this scenario, an extra block, an extra whatever. And you have to change what you're thinking to add in that new piece. So please watch it. Don't forget to use words. Oh, no, she said it. Yes, I did. You can't just use equations. You have to explain what's going on. That's the big difference between the old physics exams and the new ones. Don't forget to explain. And let me see if I can attempt to draw. Don't laugh at my drawing. I try hard. I just don't draw well. Some of you were asking about amplitude. Ooh, that's a pretty good straight line. Good. So remember, we have, okay, pretend it looks like simple harmonic motion. Yeah, love my drawings, I know. Amplitude that you're looking at, I believe that was what the question was. Remember, this is going to be my amplitude above and below, okay? Now, simple harmonic is probably the area where your teacher skipped a bit, okay? Hopefully you remember amplitude, you remember period, amplitude, and I think the other one was frequency. I apologize for my messy handwriting. Okay. Now, hopefully you remember, frequency with a very strange looking Y. Hopefully you remember between period and we have a mass on a spring, which was 2 pi square root of, anybody remember? Mass over K. And we have a very similar equation for period of a pendulum with it L over G. Now, if you think about it, and I don't have a spring, but I have a little minion, okay? So if my minion is my block and it goes back and forth and back and forth, if right here by my nose is equilibrium position, at equilibrium position, do I have the most force to bring me to equilibrium? Do I have the most acceleration? Or do I have the most velocity when I'm here at equilibrium? When I'm here at equilibrium, I'm going to have the fastest or biggest velocity. As my little minion goes to one side and then to the other side, at these edges, as far as I can go, or in other words, my greatest amplitude, what's happening? I want to go back to equilibrium as best as I can. So at these edges, this is going to be where we have our largest restoring force to pull us back to equilibrium. And this is also the location where we're going to have the greatest acceleration. Now, there have been a couple of practice problems that we were working on a couple of days ago. So when we're looking at this, we could look at this as our position here and our time here. And we could see how we're going, let's say, to a maximum, very crooked, maximum X or positive amplitude, and then down roughly to a minimum amplitude. All amplitude really is how far I'm moving that spring from one side to the other. Or if it's a pendulum, how far I'm swinging that pendulum from one side to the other. If it helps you to see it, a lot of my students sometimes call this just X so that they see it. So I'm going over a certain displacement one side or a certain displacement the other side. And then for some reason, it helps them to see it a little bit better. One other thing I want to mention in regards to amplitude and springs, I'll write it here at the top. Remember, we have force is equal to negative Kx. And we also have, depending on your teacher, they might write it like this, potential energy elastic, or perhaps U elastic like this, and they write it as 1/2 Kx squared. Why I'm mentioning this, 2 points. First point, this negative sign, for the most part, you're not going to deal with it. All it's really saying is that if I move this way, I'm going to have a force back. So my displacement's that way and my force is back this way. Or if I move here, my force wants to come back, but my displacement's that way. So they're in opposite signs. Pretty much you don't normally have to answer anything about that, not in Physics 1. Why I also wanted to bring this up is here with this X. Please realize, I don't care that this is how big the spring is. What I care about is how much I stretch this spring or compress this spring. That's the X I care about. So I don't care about how big this little spring is. I care about what I do to the spring to make it bigger or smaller. And that's going to be the X we're putting in. One question I'm asking you guys, look at those two period equations. If I look at that and I am a pendulum, will it matter which planet I'm on? What do you think? Yes or no? The answer is yes. Why? Because on the planet, you have gravity, and gravity is in the equation. Would it matter for a mass on a spring? Look at the equation. Is there anything about the gravitational pull in that one? So it's easier to measure without gravity for that mass on the spring. So what's controlling the mass on the spring is that spring constant. What's controlling that pendulum is going to be the length and the gravity of the planet that you're on. Hopefully I got that question for you. Oops, let me get my little arrow. All right. Now, remember, for multiple choice, how many I answered correctly. That's all you care about. There's no longer any deduction. And remember, those last 5 are going to be those double response. Now, on those double response, what if I get one of the parts right and not the other part? Does it count? No, you have to get both parts right. So if I kind of suggest you leave those to the end, because it takes just a little bit longer for a person to process those than it does to do the single responses. If you can, eliminate the incorrect responses. So if you see something that's just totally wackadoodles, mark it off, look at the other 2 or 3 that you have there. Do an estimation, especially on the multiple choice. Do something like about 10 times something. Okay, it's about 10 to the something power, so that you can eliminate anything that's really off and shorten your time on those multiple choice. Somebody asked me today in class, can I go from my multiple choice to the free response and start the free response early? No, you cannot. The multiple choice is a fixed time, then you have your break, then you'll have your free response. So no, you can't move from one section to another. You may wish to derive things symbolically. My students go straight for the math first and then put it in symbols or in an expression. It depends on how you've been taught. Either way is correct, and you can go there. I will leave this. Now, as far as your answer sheets, we are all human and you're going to be tired, and that's okay. Just check yourself. Sometimes if you're skipping a problem because you just don't know that answer and you move on, but you forget on your answer sheet and you bubble it anyhow, be careful that you're bubbling the correct number. So if you're on number 5, make sure you're bubbling number 5, and so on. Just check yourself every 5 or so questions to make sure you're right on target. It isn't a frequent mistake, but it usually happens sometime during the year to most of us. So just watch yourself and check. Now, free response, after you've had that 10-minute break and you're stretching, you're all good, you're ready to go for it. Take some nice deep breaths during that free response, right before that free response, and get some air in your lungs so that you'll be ready. I would suggest for free response, first thing you do is open it and look at every question. Now, some teachers don't agree with me, but I do. The reason why is because once you look at all 5 questions, you'll see the one that you like the best. And I'd start there because the point values are right there on the problem, so you know how long you're taking. But if you can knock out one of them, your stress level comes right down. You start working on the second one and you keep coming down. So then you get to that last one that, yeah, you're going to struggle with, but it's okay because you know already in your head, you've done these other ones and you've done your best on them. So please look through all of them, even if it's just for a short little minute or so, that you can say, okay, I'm going to start here. I tell the story, and it's true. One year on what used to be considered the B exam, a lot of people got stuck on number 1. And I still remember the question too. I won't go and tell you, but yes, everybody got stuck on number 1. And my students knew that I would tell them, move on if you don't get it. And they did 2, 3, and 4, and then came back to number 1 and put some things down. The whole group scored a 5. And the reason why is because the whole nation kind of got stuck there. And my students didn't get stuck there. They went on, did everything they could, and then came back to that very difficult problem. So please start where it is you wish to start. Now, solve the questions that you can maximize your points. Now, what do I mean by that? What I mean is that you don't have to get every single point on every single free response to get your 5. You don't. What I want you to do is get every single point you can. So if I'm working, say, one of those big ones, the QQT or the experimental, and that last little, part F double I that they have there, that one's really giving me trouble, but I finished the rest of it. Great, move on to something else I can do and get it right. So that 1 or 2 points there at the end, I can pick up somewhere else and still score decently. I want to maximize my points. Now, I do happen to help grade these AP exams, and as we grade, we have to read your handwriting. So please clearly indicate where you're going, because sometimes you're working a problem, and then you want to send us over here. No problem. Draw us an arrow. We're intelligent people. We can follow your arrow and follow your work. Just show us where you're going. If I can't tell what I'm reading and I don't know what part I'm doing, then I can't give you credit for it. So you want to make sure that whoever's grading it, we see exactly what you want us to see. If you're working and all of a sudden, oh, this is not what I want, cross it off, move over, and let us know where we're supposed to read and where we're supposed to grade. One thing that students tend to do is, you're nervous, you write down all the equations that have that variable in it. That's not going to help you. We're not going to just give you points because you wrote down a bunch of equations and copied them from the equation sheet. If you put down the right equation to work the problem, yes, of course, but then you need to start using that equation. So one of the old philosophies was, write everything down that has to do with it. Don't. I want you to be intelligent and kind of edit yourself as you go so that you're putting down something that's relevant to the question. Everybody, no matter where you are taking this AP exam, you're going to get your equation sheet. Same one your teacher's been using all year. You're also going to get that same constant sheet. So big G, no, you didn't have to memorize big G, okay? It's going to be on there for you. So don't worry, you don't have to try to memorize that tonight. Now, organize your answers. If it's an answer to part A, put it in that section. Well, let's say I wrote part A and I totally messed up. I crossed it off and I drew an arrow down and said, here's my part A. I can follow that. And maybe you split it and put part B over here, but it's labeled and arrows are in the right places. We can follow that. We'll grade that appropriately. Do tell us whatever that equation is that it is you're using. Do tell us the physics behind what you're doing. Show me the steps. I'm sure your teachers have worked with you with some practice FRQs. And if not, maybe you've gone onto the College Board website and done it yourself. Good for you. If you've done that and you've ever looked at one of those answer keys, notice what they're doing. If, let's say it's a conservation of energy or conservation of momentum, if you put the words conservation of energy or conservation of momentum and maybe the equation, that's probably worth 1 point. And then probably substituting something in, whatever variables they're giving you, you're probably earning a 2nd point. And maybe manipulating it to get whatever they're asking, that's probably your 3rd point on maybe part A. That's very doable. You guys can do that, okay? So try that kind of philosophy. Put it down on paper. We as the graders or readers, we don't know what's in your head. You have to tell us. So please write it down. The easier the person can read it and follow you, the better it is. And some of my students often say, well, what if, because I'm nervous, I need to write all my algebraic steps to see what I'm doing? Okay. The grader's not going to be upset about that. They're going to sit there and, oh, okay, I see exactly what this student's doing. Now, will they give you points for every single line of the algebraic manipulation? No, but they'll be able to find the points in there to probably give you those points. So please make sure you're clear. And if you need extra space, use it. Show your work for every question. Oh no, she said that. Yes. Don't give us bullet answers, guys. I know your teachers mark off for it. I mark off for it, but the graders will be marking off for it too. Remember, the answer itself is probably just worth 1, but you might have a 5 points that you could earn in there. You need to show us the other parts of the work so we can give you that. So partial credit is indeed totally possible and is the best thing about that for your response because you can get points every which way in there. Now, the last bullet here I want to particularly say, full credit is often based not just on the presence of that right answer, but the correct use of the appropriate steps. So telling me 5 meters per second or the period is 5 seconds, that's great. You'll earn that single point. But remember, we want to see your thought process. That's really the beauty behind this Physics 1 test, is to show us how you think. And that's really the power of it. Now, let's say I messed up. I'm on part A. I did everything wrong. I got a number that said 15, 15 meters, okay? But then I had to use that 15 meters in part B and part C and so on. As a grader, we'll mark off on part A, but we'll notice that you use that same number through the rest of the parts, A, B, C, double I, and all that stuff. And we will give you credit on those other parts as long as you worked those correctly. So there is a part to our grading where we'll actually look at what you did and then, if needed, take that incorrect number and recalculate. We have little calculators sitting there with us. So if we need to, we do. And then you could earn full credit on the rest of the problem, even though you lost credit on part A. Not too bad. Huh? Please don't sit there the whole time and trying to erase everything. Just cross it off and allow yourself to move on. Simplification. I know we're all in various math classes. No, you don't always have to simplify it into the most perfect terms. Get it down to cleaning it up and solving for what they want, and then you can leave it and move on. Watch your units though, especially if you're getting yourself stuck. You can probably find something in the units to fix yourself as you're working the problem. So if you need to, check those units out to help yourself. And about once every, I want to say about 5-ish years, they give you 1 point for units. It used to be all the time, but they don't do it very often now. It does happen though. Maybe this year will be the year. One of the hardest questions, I think, in the free response is learning to justify yourself. So when they're asking you to justify your answer, you actually have to use these dreaded things called words. Oh my goodness. Yes. So that's hard for some people. So here's a hint. Write it down as an equation and then write down the words to make that equation. So if you're saying some sort of y equals mx plus b, okay, so I'm looking at the change in height is equal to da, 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 da. So if it helps you on the side, write that little equation and then use that as the crutch to be able to write the words. Please show the grader how you're getting your answer and prove why you are correct. Why is your math correct? What is it that you're doing to show me that you've got it right? Now, also remember it's divided into parts. So we've got 5 questions. Each one of those 5 questions has an A, B, C, however many, and they may have, because College Board loves I and double I. No problem. Do each section. Even when I'm teaching, sometimes I get the I and double I kind of mixed in because I'm working it. Again, point it to the right spot so that we know where to use it. Okay. Pitfalls, because we're human. When we get to the paragraph length response, that's going to be one of my 3 short answer problems. On that paragraph length response, you've got a really good chance of nailing that one. For those 7 points, the first point to 2 points is going to be some sort of scenario. A graph you're looking at, a demonstration you're looking at, a claim from somebody that you're looking at. You're going to have to agree or disagree with whatever this is or be able to identify it. At that point, that was probably 1 or 2 points out of your 7. Then comes your paragraph. So your paragraph is probably going to be worth 5 points, maybe 6 if you had a weird one, but 5 points. One of those points is for a clear, coherent, logical scenario. Did you hear me say that it was right? No, but that you're making sense and that you're using physics and the person can follow you probably could give you at least 1 point. That's doable. That's real doable. Okay. Now to get the rest of them, most of your teachers practice that claim evidence reasoning. You even use this in your English class. So make a claim about whatever the scenario is. So answer that. Then I want you to use evidence from what you know about physics. Well, what do I mean? Well, if it is something that's, say, simple harmonics, since you were asking about amplitude, is it that an extra block, extra mass was added? Is it that you increased the period? What's happening? Okay, well, what if it's an example like I did? If I take that mass or block moving back and forth horizontally and I put it on another planet, is that going to change this oscillation? Remember from our equation, we said no. So we would say that the equation is this, that gravity is not in the equation, so therefore it will not change the period of oscillation, and it would not change the amplitude of it. Okay, maybe they have a second part to it, okay, and they ask you, well, what if I added more mass to it? What would happen? Now, one thing I do want to share, hold on, let me have my little thing. Let's say we did have that period equation, just because I was thinking of it. Okay. If I tell you that I doubled the mass, what would happen to my period? Now, some people see it right off the top of their head, and they're not nervous at all. What I suggest is something called the Mooney's factor change. Anything that's the same, put a 1. So the 2 stays the same, I'm going to put a 1. The pi stays the same. I'm going to put a 1. I said, let's increase the mass. So let's say maybe 4 times, put a 4, and the k stays the same. So what would happen to my period? I bet you can guess. All of those 1s will pretty much go away. So my period is going to change by square root of 4, or period will be 2 times the amount. Can you see it? It helps a lot. This can help you on the multiple choice. It can also help you on the free response when you're comparing different things, because a lot of the times they'll give you an equation and say, does this make sense? Or what would happen if I increase the whatever? So if you put 1s for all the things that stay the same and put a factor in for the thing that changes, it should help you be able to find your answer. Now, once you've kind of found your answer and you provided that evidence, give us some actual physics behind it in words. So you've shown it mathematically, you've told us what you're doing. Now, don't forget to include the physics of the why. Okay, that why is often important. This graph implies this changing of the mass suggests that the period would be twice as much, and so on. So kind of frame it so that we can work with you. Okay, we get to the next one. Oftentimes use the physics vocabulary that's right there for you. Now we have native speakers of English and non-native speakers. Both of you use those words that are on that beautiful equation sheet. It's a cheat sheet for you, okay? They're spelled right. These are the words we physics people want to see in your answers. Use them, okay? Those are great nouns that are there. Use the equations that are there. Also, other verbs that you've been using all year. Ooh, wait, I've got a list. Great. Some of these are task verbs. So task verbs will tell you what to do. If I'm deriving, I want an equation. If I'm calculating, I'm using that equation to solve for some sort of number. Sketching versus plotting. Sketching is just give me a curve. Plot is actually plot the points. All of these are the biggies of what you want. Remember, when I'm wanting words, I'm going to want words here with justify. I'm going to want words with derive. I'm going to want words with describe and explain. Okay, so you're going to be telling me in words what you're saying based on the physics. Cool. Okay. 1 second. I see rotational. Like assistant work. I'm reading your chat. Okay, perfect. Another piece. This on the right-hand side is the physics graph paper. Now, your teachers may have warned you. I warn you as well. You want to use about 3/4 of this piece of graph paper. Okay? Many students like to draw little tiny bitty size graphs. That's very hard to read for us old people reading your papers, but it's also very hard to read to see a curve. If you're spreading it out, we're going to be able to see, is it a quadratic? Is it not a quadratic? And so on. And so will you. So use that graph paper, at least 3/4 of it. Remember, on your free bodies, don't forget to make sure that the arrow or ray is touching the body, okay? So you're going to want to make sure that if this is the dot they're providing, your arrow is touching it. Don't forget to label what your arrow is. Is it weight? Is it normal? Is it friction? What is it? That's how you get those easy points from the free body diagrams. Additionally, you see this equation here with circular motion. That is not on your equation sheet. Many people forget it and get stuck. Think about it like this. If here's my circle and I start here, I'm going to go all the way around, so the circumference in a certain amount of time. So if I'm doing a how far I went, that's an x over a t, but in our case, it's circumference over time, and that's where you get this velocity. Many, many people forget that one on a test, and they usually have you plugging and chugging with it. Okay, and let me go here. Sorry, it's all the way in the corner for me. Silly, I know. Slope dude, I'm sure you've heard it. When you're getting to graphing, don't forget The eyebrow that's going up is a positive slope. The eyebrow going down is a negative slope. Straight up and down is undefined. The U of the nose, it's silly, I know, but it helps. When he's not happy, there's zeros for his cheeks. So when it's a horizontal line, there is no slope, okay? Where it's a vertical line, the nose is undefined. Most of the time, we're going to have the positive, negative, and the zero. Now, since I have room, actually, let me use this space because I have more room there. Let's see, velocity, rotational. Okay, I'm just reading your list. Okay. Here we go. Again, forgive my handwriting. Many of us don't get all the way through rotation. So let me put you at ease. We used to do X, V, and A. So displacement, velocity, and acceleration. We did this with projectiles and cars and all sorts of stuff. When we move to rotational motion, the displacement becomes an angle theta. The velocity becomes an omega, which is a funny looking W, and A, or acceleration, becomes alpha. Now, we have the ability to connect these things. So how do I get from one to the other? The equation is X is equal to R theta, V is equal to R omega, and A is equal to R alpha. That's not too bad to remember, okay? That's our translation between the two. Now, if you haven't gotten there, let me just show you. You have change of X, let's say, old kinematics. I'm just going to pick one of them. How do I make that into the exact same thing, but for a rotating object? I can make that now change of theta is omega naught t plus 1/2 alpha t squared. So the linear and the angular are very much connected. And you can do that for each one, of your kinematic equations. Similarly, I see somebody said about torque. What do we have for Newton's second law? Newton's second law is F is equal to ma. You've done gobs of problems that way. Well, when we get to torque, there's a rotational equivalent. For torque, we will have I, the inertia, times alpha. Now, maybe your teacher didn't get to I. What is I? I, or the inertia, is how much I as a body resist rotating. Usually, the inertia is going to be some sort of coefficient and then an mr squared. And then again, we'll have our alpha over here. Well, how do I know what this coefficient is that goes in front? Perhaps you've done some labs, but don't have any fear if you haven't. At this point in AP Physics 1, they give you the inertia. They'll tell you that it's a 1 here or that it's a 1/3. They tell you on the question. Or they'll just tell you that I equals some number, and they're going to tell you the number. So don't have a worry if you haven't had experience with that. They're going to tell you in the problem itself. Yay. Okay. Also, when you're talking torque, let me just get a little more space. There we go. Torque is also equal to force times the lever arm. What's a lever arm? A lever arm is how far you are from the pivot point. So for example, if I have an object like this and I put the pivot here, from here to here, if I had a force, that would be my lever arm. This would be my L. Okay, well, what if I had something here? Would it be the total? No, it's from the pivot directly to this location. So it's from pivot to wherever you're pushing or pulling. Now, I did not draw beautifully, but I shall try to draw one additional one here. What if it was at the angle like this? Would it be that we're looking at, let's see if I can get this spot or this spot, point A for a side or point B for a side? Would it be A or B that's going to make me rotate this bar? Give you a minute to think. Hopefully you said A. A will help me rotate because remember, for that bar, we can rotate clockwise or we can rotate counterclockwise. So clockwise is often abbreviated CW, I know you know, and counterclockwise is CW. We tend to do a lot of math, so that counterclockwise is going to be our positive, like a unit circle, and our clockwise is going to be our negative. Okay, let's see, other questions. Rotational stuff, what else can I think of? Another thing for rotational. If you remember, we used to do kinetic energy, perhaps like this, or perhaps like this. Kinetic energy was 1/2 mv squared. You've done a gazillion like that. Now, that kind of kinetic energy, isn't that an object going from here to here? What do we call that? That's going to be called translational. So it's going from one spot to another spot. Guess what? It has a rotational component too. So couldn't we say kinetic energy rotational or K rotational? Anybody remember? That's going to be also 1/2. And instead of M, we're going to put I, that same inertia. And instead of V, we're going to put omega squared. You see how it goes from linear to angular? It's beautiful. Also, didn't we used to have momentum? Is there an angular version of that one? Yes. That's going to be L is equal to I omega. Notice, for the most part, all of our linear stuff becomes angular. And the big kind of connecting part would be M's turn into I's. Okay, so mass turns into inertia. Linear velocities turn into angular velocities. And there's that connection between them. I often find myself using these three that link angular and linear to be able to place into equations to be able to solve for whatever it is that they're asking for. Let's see, what else did you write? Okay, 1 second, let me clear the board. How am I on time? I'm still okay? Let me try to finish. There was another question in terms of boxes pushing against each other like a system or forces involving tensions. Okay. I think what you're trying to ask me is, let's say we had something like this with maybe a pulley and perhaps a box, something coming over the pulley, something like this, like an Atwood machine. The best suggestion I can say, there are two versions of ways to do this. You can use the entire thing together as a system and look at the system accelerating, or some people will do it as, let's call this block A and this block B. They will do the sum of forces relative to A and the sum of forces relative to B, and then put the tensions equal to each other. So it kind of depends on which way you were taught. Some people like to do that as one whole system. Some people like to do that as two separate objects, but it is a choice. Another person asked a question about, say, maybe it's a person in an elevator or something, and say that's the person. I know, I drew beautifully. And they're on a scale in a big old elevator that's going up. We would have the weight of the person coming down, and they're standing on something, so they would have the normal force pushing up. Now, if the elevator is at rest, the sum of forces in that y direction, it's at rest, so that MA in the y direction would be 0. We're going to have normal equaling, normal, where's my eraser? Right there, minus the weight. Well, what changes? What happens if all of a sudden this elevator is moving this way with some sort of acceleration? The normal and the weight are still pointing in the same direction. This is what changes. Now we can't make that MA a 0. We're going to have MA as an actual number, solving for normal, is usually what they're asking for. So if we solve for normal, we'd have MA plus our MG. Isn't that true when you get in an elevator and it's going up really fast? You kind of feel like, oh, really leaden, like it's pushed you down. Okay? I think I've gotten just about all of those ones. Let me give you one quick or two quick little tidbits before I have to let you go. Graphing wise, maybe you want to take a quick screenshot. Hopefully that'll help. Oftentimes we have linear graphs, yes, in physics, but we also oftentimes get three major types of curves. One is a quadratic, second one square root, third one is going to be inverse. Here for the quadratic, they oftentimes will ask you to transform or linearize that data. When you do so, I suggest you square the x value and it will straighten the data right out. And you'll be able to do your y equals mx plus b and get your equation for your line. So that would be what I would suggest on your quadratics. Here for the square root graph, that's the one that kind of piddles out. This one you would probably see with, say, the period that we were doing for the pendulum or the mass on the spring. The best way to straighten this one out would be square that y value. And again, you're going to straighten it right out. Then you can do your slope. You can get that value. The last one there, and oh, wait, I didn't give you a chance to take a screenshot. Sorry. Take a screenshot. Okay, good. All right. And then here for the inverse one. Now, I know this one's weird. Isn't it weird looking? Many people, when you start graphing this, me included, when I was your age, I'd be like, oh, am I doing something wrong? Okay, because it comes out like this funny looking L. It's okay. You're actually correct. And it does happen. So what we can do is straighten this one out. And the best way to do that is here, as you see, the x to the -1. Now that's a little bit old school in how it's written. Perhaps you might see it better if I said 1 over x. If I said that, that's a little easier. That's exactly what you can do to straighten it out. And if you do have something that's an inverse, take a moment to graph it. Don't be mad at yourself, like you can graph it as quickly with a normal line. This one takes just a little bit more care to make sure you're doing it properly. And speaking of graphs, please make sure you're telling me who's on the y-axis and who's on the x-axis. You need to tell us. You need to make sure your divisions are equal. And you say, but I know that, Miss Ruiz. You're right, you do. But you're nervous. So if this is 2, 4, and I put 10 here, and then 20, and then 50, am I going to get credit for this? No. Remember, they have to be equal increments. So this is incorrect. I started out great, but I kind of piddled out, didn't I? Shouldn't I do something more like, let's say, 2, 4, then what, 6, 8, 10? I'm good. Well, does this other axis have to match? No. What if I just had very big numbers? Maybe on this side, I'm going to do 10, 20, 30, and so on. That's okay. Just please make sure whatever axis you're on, that you're making equal increments all the way. Being a student, and I was a student too, so I've done it too. What if I just don't feel like graphing it that way and I want to put a break in the data? Okay, and I want to put a break in the data, and I put that little squiggly line and I start at 50 and then I go to 100 and such. I know you can do it, and I know you're good at doing it. I'm going to ask you not to do it. The reason why is if you're putting that break, most likely it's going to be a curve of some nature, and we're going to see something at those smaller values that's going to give us either a square root or a quadratic. So if you can, try not to put that break in the data so that you can actually show us what's going on. Okay, I hope. All right, hopefully I convinced you. All right. Also, I know it's what time? About 9:19 or so, 9:20. Well, here in Eastern Standard Time. I'm not sure where you guys are living, but in Eastern Standard Time. I'd be tempted to stay up all night too and study and do 20 more problems. May I humbly suggest that you go over a little bit from each unit and go to bed. Physics is not a memorize and spit out the answer type of test. It's not a remember and recall. It's a thinking test. You have to be rested, you have to be on, and you're going to be tired when you're done with the test. So you need to realize you have to go in there, you're going to get a problem, you're going to have to think about the physics and then answer to the very best of your ability. It's not like a repetitive nature. It's not a math problem. It's not a statistics or a calculus problem where there's kind of designated kinds and they're changing variables. This is a new situation, a new thing every year, every time. They send out these questions and a bunch of people teaching physics, including college professors, send in questions and they pick the best ones and tweak them. That's what you're getting. So you're going to have a scenario and you're going to have to think about it. And then you're going to have to answer with your best physics. So do not stay up till midnight, people. Go to bed. Okay, so you can wake up in the morning and kick this test. I would also suggest that as you're looking at the test, pay particular attention to any picture that they've drawn, whether that picture is a diagram of a lab situation, or the picture is a graph of something, or if they've actually typed out an equation where they're saying compare student 1 and student 2. Those things are critical for you to look at. Think of it from this perspective. That costs more ink for them to print. That costs an extra person to have to draw it or write it and proof it. And then they had to get it on the paper perfectly for you to be able to read it. So it costs a substantial amount of money extra to put that piece. If College Board thought it was important enough to spend that money, it's important enough for you to read it. Every graph you see on a physics test is important. Every graph you see on a physics test is probably resembling one of the equations that's on that equation sheet. So look at the slope. The slope has meaning. Look at the area under the curve. The area under the curve has meaning. Look at the units. See what's there. Do that kind of methodical nature of looking at things, and it should serve you well. When you are looking at the equations and comparing them, please, please, please do that factor change method I was showing you. Okay. Anybody have something I have not answered yet? Please tell me in chat. If there's like 1 or 2 more, I can get in there before you guys are going to bed early. Anything else? Or shall I just keep telling you what I think is going to be on? I do think. Are we good?
And Gina, yeah, hey, it's everyone. It's John from Marco Learning. I've just been seeing in the chat too. First of all, it's going to be good vibes only. So I'm having people fill this up with tomorrow I will slay to wash out all the people who are saying they're about to bomb and get a zero, and they just stay up all night. One thing that people have been talking about are these unlisted equations. So what is the difference between the equations on Physics 1 that we can reference throughout the test and the ones that we should be memorizing the night before? Or are we at a point where it's like it's not about memorizing this?
The ones that they're giving you on the equation sheet, the best I can suggest to you is you need to be able to be comfortable with just that manipulation back and forth. And the key that, where'd my pen go? Oh. The key that I want to mention is something like this. Remember how I had told you that this one was not on the equation sheet, this velocity one? Why is it important? Well, what if I was doing Newton's universal law of gravitation and centripetal force? Remember, centripetal force is not its own entity. It's a mass times an acceleration. And if I put that equal to, let's say, gravitational force, I'm going to cancel my mass, right? And I'm going to get that velocity. Oops, sorry, I should have canceled that R. Excuse me. There we go. And we will be here at this location, but this is the mass of the central object divided by R. Well, in past tests, we've had to take this velocity and use this equation inside there. That's what you really need to be able to do. And it's not just that one. There are multiple equations where you're going to use a piece of somebody inside somebody else. So the equation isn't already, in a sense, built for you. You're building it. So let's say I was doing this one. I would have 2 pi r over t, square it, equaling big G, mass of the central object r. And maybe at that point, they're having me solve for r, or the mass of the central object, or whatever. In a sense, you're going to use something in something else. They do this very frequently with circular motion. It's extremely frequent with circular motion. Another one that's very frequent is, if you remember, I had said V is equal to R omega. We are oftentimes substituting in for omega, V over R. So it's not that it isn't given to you, it's that you have to build or combine equations to get it. Does that make sense? Other questions I didn't get to.
Yeah, the big question that everyone has is, where's our dog Marco?
I don't
which is
know.
Yeah, so here's what we're going to do, everyone. Gina, you can go ahead and stop sharing this. Everyone,
Okay.
I wanted to just reiterate something really important that Gina was mentioning earlier, Miss Ruiz Houston, which is, you're not, in the next few minutes or hours, you are not radically transforming your performance on the test through studying. You're radically transforming your performance on the test through getting your mind and your body in the right place, getting a full night's rest. Every single study ever done on sleep and exam performance shows a direct correlation between the amount of sleep you get and the way that you perform on test day. The other thing is, people, we have a therapy dog. I'm going to bring him live on the camera now. This is Marco. I'm John from Marco. This is Marco from Marco, and he is going to give you all a little blessing before you go to bed. So I want to see those little sheep emoji in the chat to just fill it up. You can find it with your little emoji things, copy and paste it. I want to see a bunch of sheepdogs. Well, I get him up on the screen and we wrap up and say goodnight to you all. So give me 1 second.
And he's not a teeny tiny dog. He's a big dog.
Here he is. There's Marco. Everyone, you can take your picture of Marco now.
He's such a sweetie.
He's appeared on Instagram, TikTok, Twitter, all your favorite social media platforms, giving a little blessing to all the physics students.
Yes.
So, and you can see, I mean, can't talk about calculating centripetal force. Centripetal force on my back right now, the torque, the tension, and here he is. He's and this I don't know, something about velocity.
Oh.
As the gravity took him to the floor and broke every muscle and bone of my body. People, if I can overcome picking up this dog who's 375 pounds, mostly fur,
Oh my gosh.
you can do well in your exam tomorrow. So everyone, go into your AP Physics exam, slay it.
Mm-hmm.
Say hi to us on Instagram and TikTok and the places that you know us from. Ms. Ruiz-Houston, any final words of wisdom for our physics students?
Yes. Believe in yourself. You
Amen.
know more than you think you do. Put what's here on paper and let us give you credit for it. Okay?
Yeah, and everyone, as we wrap up tonight, I want you to write in all caps, I believe in myself, in the chat. It's just to wash off all the negativity of other people talking about getting ones, of all the things you didn't know 5 months ago, of everything. So good luck, everyone. You will do
amazing.
You will do amazing, and you will write, I believe in myself, in the chat. So with that, everyone, good night, and we will see you tomorrow when we hear about how it went. Thanks, everyone.
Bye-bye.